Okay, now this question is about methods of separation from mixtures. The first question is describe to separate the following. In each example, give the description of the procedure used and explain why this method works. The first question over here is copper powder from the mixture containing copper and zinc powder. It means I want copper powder from the mixture of copper and zinc. Both of them are in the powder form. Correct. Now here we are going to use activity series of metals. Over here you are having powder of copper. Symbol of copper is Cu. Symbol of zinc is Zn. Okay, zinc is more reactive metal, copper is less reactive metal. I am going to make it react with any dilute acid. For example, I am going to make it react with dilute HCl, hydrochloric acid. Now zinc will react with dilute hydrochloric acid. I'll give you the reaction also. Copper is not going to react because it is below hydrogen in the activity series. So there is no reaction for copper. Copper powder is going to remain as it is, and then you are going to carry out filtration of copper powder. I'm explaining in short the whole procedure once again. You are having mixture of copper powder and zinc powder. Hydrochloric acid will react with zinc, copper will not react. I'll give you the activity series of metals. Okay, whichever metals are above hydrogen in the activity series, they will react with any acid. Whichever metals are below hydrogen in the activity series, they will not react with acid. So zinc and dilute hydrochloric acid will react. That will become a solution. Copper will not react. That will remain in the powder form. We will carry out filtration. Okay. So the procedure over here is add dilute HCl to the mixture. This is the procedure. Explanation is no reaction. Of course, I will write also here. Then filter copper powder. No reaction of copper with HCl. Zinc reacts with HCl. I'll also give the reaction. The reaction is very simple. Zn plus HCl. This is going to give a zinc chloride, which is ZnCl2, and it will liberate hydrogen gas, which is H2. I'll also give you the state symbols. This is a solid. This is aqueous. This is also water soluble. So this is aqueous. And hydrogen is a gas. What will remain behind is going to be mixture of zinc chloride and copper powder. Copper powder is a solid. We'll carry out filtration. So copper powder will be obtained from the mixture of zinc powder and copper powder. This is the proper answer for the first question. If you have any questions, you can ask me. Otherwise, take down this answer, whatever is there on screen. Now, the B part of the question, we have to separate nitrogen from the mixture of nitrogen and oxygen. Now, at room temperature, both of these are gases. But if you are going to cool it at much lower temperature, they will get liquefied. They will get converted into the mixture of liquid nitrogen and liquid oxygen. The boiling point of both of these substances are different. Okay, nitrogen has much lower boiling point than oxygen. Whenever two liquids have different boiling points, we can separate them out by the process of distillation. I'll send you the link for the process of distillation. I will also explain you what is the meaning of distillation. We just boil off the mixture whichever is the lower boiling liquid that will start boiling first. I'll give you one simple example for this. Let us take here at room temperature only. We are having mixture of water and alcohol. Water, the boiling point is 100 degrees Celsius. Alcohol, the boiling point is 80, that is 78 degrees Celsius. If you are having mixture of water and alcohol, 100 degrees Celsius, 78 degrees Celsius boiling points, in that case, the mixture will be boiled. So first we are going to reach the temperature of 78 degrees Celsius when you heat it. So 78 degrees Celsius is a lower temperature, so alcohol will start boiling first and water will remain behind because its boiling point is 100. So all the alcohol will boil off first, what will remain behind is going to be water. This is how the distillation process is going to take place. There is one more procedure for this, which is also known as fractional distillation. This process is simple distillation because the boiling point difference is more than 20 degrees Celsius. If the boiling point is very, very less, even it can be 0.5 degrees Celsius also. In such cases, we are going to use fractional distillation. Fractional distillation will be used when the boiling point difference is very, very less, especially when we are carrying out of substances, when we come across through organic chemicals. Boiling point difference will be around 0.5 degrees Celsius. Even those substances also we can separate them out. So over here, simple distillation is the process. I'll give you the diagram also. And also I will give you the diagram for fractional distillation. First, I'll answer this question. Okay. Fractional distillation of mixture of liquefied gases explanation is differences in boiling points separates the mixture. You will take down all of these things, whatever other explanation and diagram, etc. is there. I will just send that.